All right, good morning, everyone. Hoping that your homework went okay with the quadratic functions and quadratic inequalities. We're going to proceed into polynomial functions. We started talking about this last time. I was looking, our next test is 2 weeks from Thursday. So this Thursday, right? 2 weeks from then, we have our next test, all right? What date is that? It's the 26th. That's when we're scheduled to have it, 26th. So we'll talk about that more later. So we have a lot to do today. Let's see how it goes, all right? So last time I talked about polynomial functions, I showed you examples of polynomial functions, just like what they look like as functions. And then I did talk about how to identify the degree and the leading coefficient, right? Yes? Okay. So we ended with me talking about the properties of polynomial functions, that when you graph them, they look smooth and curved. Well, smooth and continuous, meaning you can draw it without picking up your pencil. And then if the degree, the highest power of x, is bigger than or equal to 2, it's going to be curved. So, sorry, I can't get this TV to work. So, y'all see that over there? That is an example of a polynomial function, okay? That's an example right here. And see how this left side just continues to go up? If I were to kind of zoom out, you'll see that that just continues going up forever and ever and ever and ever. So I'm going to just put arrows on the ends to imply that it goes up forever. So y'all see on this particular polynomial function, the left side goes up and the right side goes up, right? Okay, let me show you another one. Oh, also, notice it's smooth and curved, right? Here's another example. Take this out. So there's another example of a polynomial function. Notice here, the left side goes down and the right side goes up, right? And then let's do another one. By the way, we're going to graph all these by hand at some point here. There's another one. Here, the left side goes up, the right side goes up, right? So on all polynomial functions, I'll just graph a few more of these. On all polynomial functions, there is an easy way. Those are all the graphs we're going to do right there. On any polynomial function we have, we should be able to determine what we call the end behavior. The left and right-hand side, we should be able to tell if it goes up or down. So we're going to have basically 4 possibilities. Either both sides go up, both sides go down, or left side goes down, right side goes up, or left side goes up, right side goes down. Those are the only possible results when it comes to a polynomial function. The good news is that to determine the end behavior, it's a very simple thing, all right? And we use something called the leading coefficient test, all right? So with the leading coefficient test, here's the way it works. And let's just look at, I'm going to look at this first example. Let me zoom in on this so you can see it. Let's take a look at that function right there. I'm calling it f sub 1. Just don't worry about the fact that I subscripted that. Oops, hold on. All right, so let's take a look at this. F sub 1 of x is equal to x to the 4th minus 8x cubed plus 15x squared. Somebody texted me and asked me if we're having a quiz today. So I'm sorry I didn't respond, but I said at the end of class there's no quiz next class. So I said it at the end of class. Okay, so there's our function, right? And the question is, how can we determine the end behavior just by looking at the function? We use this thing called the leading coefficient test. You ready? Here it goes. It's really simple. First thing you do is you identify the degree. So what's the degree of this polynomial? 4. It's the highest power of x that we see, okay? The highest power of x is called the degree, so it'd be 4, right? The next thing we do is we determine the leading coefficient. The leading coefficient. And I'm going to abbreviate that LC from now on, okay? Because I don't want to write that over and over and over. So the leading coefficient, what the hell is that? like a backpack over here. I'm not going to pick that up. So leading coefficient is the number in front of the highest power of x. So for us, there's a 1 right here, right? That is our leading coefficient, all right? And what we're going to do is we're going to look at those two numbers, and those are going to tell us everything about whether or not it does this or that or this or that, right? And the way we do it is this. For the degree, what we want to know about this number is whether or not it's even or odd. Well, of course, 4 is even, right? And then for the leading coefficient, we want to know if it's positive or negative. And in this case, it's positive, right? That tells us what we need to know. But how, how does it tell us, right? So what we do is we use a table. It's like a little table to use as a guide that'll determine this. So draw this table. Okay, on the left side, I'm going to put degree even, degree odd, and then here I'm going to put LC positive, LC negative. Make sense? When it comes to degree, it's either even or odd, and when it comes to leading coefficients, either positive or negative. So there are 4 different possibilities. So let me tell you what happens. If you have an even degree and a positive leading coefficient, I can promise you that the left side of your polynomial function will go up, the right side will also go up, and in the middle I want you to put a question mark because it can do all sorts of stuff, right? We saw the graphs and they're all wiggly on the inside. We're going to have to figure out all those wiggles, but this part is going to be the easy part, okay? So both sides will go up. If you have an even degree and the leading coefficient is negative, the left side goes down, the right side goes down, and in the middle there's, well, we don't know. We have to figure that out, okay? One way you can remember this, I think it's pretty simple to remember this, is x squared, right? We all know what x squared looks like, right? Parabola? That's even, isn't it? So this is positive x squared, that would be negative x squared. So you can kind of remember it that way if you have trouble remembering the table. And then if we have an odd degree and a positive leading coefficient, the left side goes down, the right side goes up. And if you have odd degree and negative leading coefficient, left side goes up and right side goes down, and then in the middle we don't know. So those are our 4 possibilities. Now I want to discuss with you a little bit why it's this, okay? Because most of you are going to be in calculus, and so when you get to calculus, we want to think about it a little bit more deeply. Is that a word? More deeply? Little. Yeah. We need to understand why it's these things. All right. So in this case, right, even degree, positive leading coefficient. Why do both sides go up? Well, if you think about graphing it, right, what we're saying is that as you go out to the right, right, as you go out to the right, as you let your x values get what? Real big and positive, what would happen? What would happen if I put a really big positive number here and raise it to the 4th power? It would still be positive and it would be huge, wouldn't it? Yes? Now, what if I put that same big positive number here and cubed it? That would be big, yes? And then I put -8, wouldn't that make this negative? Are y'all thinking about the numbers here? You need to be thinking about what would happen. This is a really, really big number, right? Because I raised it to the 4th. This is also big, but I raised it to the 3rd. So if this number is really big, this term right here should dominate all other terms. Like, it doesn't matter what these turn out to be. Because this is the 4th power, this is the biggest power, this term dictates what this graph does when you're going really, really far. When you're in here, like in the middle, yes, maybe this term will be bigger than this one. You know, maybe this one will overwhelm this one. But if you go out far enough, this term dictates everything that's happening with the function. All right? Similarly, if you go the other way on the axis, if you make your x get really big, right, really big but negative, This was big and positive. What would happen if I put a really big negative number here? Well, I raise it to the fourth power, it becomes positive, doesn't it? So this big positive term, if you go out far enough, should overwhelm these. And again, what will happen is you'll get a big positive number. So as you go out, this term dominates, and it starts to go up on both sides. Make sense? Yeah, kind of? Okay, so what happens, let's see what happens if I change this to a negative in front here, right? If I change that to a negative, now the leading coefficient is negative, isn't it? And both sides should go down. Well, same argument. If you go out this way and you put a really big positive number here, it becomes huge and positive, but then you're making it negative, right? So now instead of doing this and going like that, you've made it negative, which reflects it over the x-axis, and now it's going down. And this side would do the same thing. Yeah? Okay, let me change it up a little bit. Let's see, do I have an odd one? No, I'll just make one up. So again, this is just so you think about it. What if I had something like this? X to the 7th minus 5x to the 4th plus 1. That's a polynomial function. The degree of this is 7, right? It's odd. The leading coefficient is 1. Well, let's make it 2 just for fun. 2. So it's still positive, right? Positive leading coefficient, odd degree. So odd degree, positive leading coefficient, left side down, right side up, right? It'll be this one. Why though? Think about this again. If you put a big positive number in here, a big positive number to the 7th is still positive, isn't it? And this becomes huge and overwhelms these because this is only fourth power. So as long as x gets big enough, this will be really dictating everything. So the right side should go up. On the other hand, if we put a really big negative number in there, what's a big negative number to the 7th power? Big and negative, right? And this should, again, overwhelm these if we go out far enough that way. So as we go out this way, it becomes big and negative, so it drops down. Okay? So just try and understand it more than just like, oh, what's the table? Try and understand what's happening. Because a lot of calculus is about number sense, about knowing the way things behave, as opposed to just trying to memorize something. All right, what do you think? Leading coefficient test, pretty simple? Pretty straightforward. Let's look at these functions. I have some examples here. And again, I apologize that I have to make you look off of this, but let's just look at those. Look at G. Look at G1. Look at G1 over there. I'm not gonna write the whole function down, okay, because you can see it over there. For G1, what's the degree? 5. What's the leading coefficient? 1. Okay, so what's the end behavior of G1? Left side does what? Left side what? Down, right side up. Odd, positive, right? So we know for G1, we should expect to see it go down and up like that. In the middle, we don't know. Okay? How about H1? What's the degree? What is it? 6. Okay, and the leading coefficient? 1. So the degree is even. The leading coefficient is positive, so we should expect up, up, right? Up, up. Even, positive. That's it. For the end behavior, that's it. Are any of these interesting? Not really. These are all pretty boring. What would J1 be? Just tell me left side, right side. J1. Left side down, right side up. How about K1? Both up. And last one, that's an L. L1, what do we got? Odd and negative, right? So up, down, up, down. Good? Most students are okay with this, but are there any questions? No? Come on.
Can you explain how those are right side?
Are you saying where does the 5 and 1 come from?
Yeah.
Well,
I know where it comes from, but how is it negative, down?
okay, so look at the degree. The degree is odd, right? Right? The degree is an odd number. So we're looking here, and then the leading coefficient is a positive number, 1. So that means you're looking here. So that's this. Got it? Anything else? No? Okay, so our challenge is going to be the question marks. That's going to be the hard part, right? The end behavior is never the hard part. So what I want to do here is I want to give us an example. We're going to look at this first example. And this one, we're going to try and see if we can graph this one without having any sort of technique. I'm not going to give you any sort of like steps. Let's just see, knowing what we know about functions, if we might be able to figure out what this does. All right? So taking f1, which is x to the 4th minus 8x cubed, and don't get too alarmed. We are going to have a set of steps to do this, all right, at some point, but not yet. All right, so let's say we want to graph this, right? The first thing I know is that the leading coefficient test, LCT, tells me that both sides go up, right? We just did that, right? We just did that. We said it was an even, right, even degree positive leading coefficient. So we know both sides go up. We just don't know the middle. Well, if we want to know what's going on in the middle, don't you think it would be helpful for us to have like the x-intercepts of the function, like where it hits the x-axis? That seems reasonable, right? And the y-intercept if we wanted that as well. So let's try and find the x-intercepts. Now, I don't know how many I'm going to have. Not right now. Remember with a parabola, you could only have, what, 2, 1, or none? Right? With this, we don't really know yet. Or, I mean, we're going to act like we don't know. The most you could ever have would be 4. But let's just act like we don't know. How do you find x-intercepts? Yes?
Does the amount of x-intercepts correlate
to the degree?
To the greatest power?
Yes, but that doesn't tell you how many you have. This tells you the most that you can have. So you could have 4, 3, 2, 1, or none. Yeah. Okay, but don't worry about that. That's not a concern of ours. All right, so we want to find the x-intercepts. How do you find the x-intercepts for any function? Solve it. Set the function equal to 0, right? Set the function equal to 0. Was that a question or you respond? Okay. So you take the function and you set it equal to 0, right? Okay, well, we can do that. We can take x to the 4th minus 8x cubed plus 15x squared. We can set that equal to 0. Unfortunately for us, that is not a quadratic, right? It's not a quadratic. But we might be able to factor it, maybe, right? If we're lucky, we can. And I see that I have first a GCF, right? There's an x squared in all of them, so I can pull that out first. And when I pull the x squared from each term, notice that the inside here is a quadratic, right? And I know how to factor quadratics as well. So I have x squared, and then I have x, let's see, this will be minus 3 and x minus 5 equals 0. So this goes back to that whole thing where you have to find two numbers that multiply to 15 and add up to be negative 8, right? I showed you all a way to do that. Is that okay? Just go here to here. Okay, this is not bad. I have 3 factors, don't I? 1, 2, 3 factors. So I can set each factor equal to 0. I'll do that over here. I'm going to rewrite it just to have it here. So I'm going to set each of these equal to 0. What I'm using there is the what's called the zero factor property. The zero factor property just says, hey, look, if you have 2 things that multiply to be 0, or 3 things that multiply to be 0, or 10 things that multiply to be 0, then you can set each of them equal to 0. All right, so what's the only solution to this? 0. The only number you can square and get 0 is 0 itself. Solve that, x is 3. And then solve this and you get x is 5. Okay. All right. We got kind of lucky here. It factored, right? So let's right now try and see if we can wrap our heads around the graph of this, all right? Like, do we have enough information to just draw like a quick kind of sketch graph? Let's see. Well, here's what I know for sure. I have an x-intercept at 0, at 3, and at 5. I find it kind of ironic. I don't know if it's ironic as a word. Remember we were talking about all that stuff with parabolas and humans not getting along and all that stuff, and then all this crap happens this weekend, right? Right. Okay, yes, we know that. Is this enough? Let's see. We also know the end behavior, don't we? So we know the left side goes up and the right side goes up. And we know it's smooth and curved, right? So do you all agree that probably from this point I should go up, right? Like it should never go up and then come back down and then go back up, right? Could it possibly come down and go through here again? No, because these are the only 3 x-intercepts I have, right? So this is probably going to go, it could wiggle a little bit. It's eventually going to go up, right? Okay, so I'm just going to put this like this. I'm probably going to connect that together, all right? I also know that the right side must go up as well, right? So over here, the graph goes up. And so is that enough information for us to graph it? No, it's not. If that's all I have, this is not enough. And here, let me show you why. Because here's one way I could do it, right? Remember, I've got to connect, I've got to get from here to here. I've got to go through those x-intercepts. And I can't pick up my pencil. It has to be smooth and curved, right? So do you agree I could do this? Yes. And then what? Come back up through that point? Now what? Come to 5. Can I cross through and come back up? No, I can't cross through. If I cross through and come back up, I'll have another x-intercept. I can't just make up my own x-intercepts. These are the only 3 I have, right? So that means I would have to like almost bounce off that. Like just touch the 5. So like bounce off and go back up, right? That's one way I could do it, right? But then, yeah, someone else could come in here and say, no. What about this? Come through here. This time, bounce off the 3, and then come back up and cross through and go like that. That's another variation, isn't it? And there's another variation as well. Let me see, do I have red? I don't think I have red. What could I do? I could come through. I could bounce off there. I could cross through here and cross through there, couldn't I? Do y'all see all those different variations? You could also think of another one, which would be pretty damn crazy, but you could bounce off all of them. Like you come and bounce off and bounce off and bounce off. You see? So which is it, right? Which is it? Well, there's a way to tell, all right? There's a way to tell which of these it is. And it requires we got to go back to this right here. We got to go back to this where we have it factored right here. And we need to determine what is called the multiplicity. The multiplicity of these factors. Okay, the multiplicity. So what am I talking about multiplicity? It's the first time I'm using this word in here. So I have to determine this thing called the multiplicity of the factor. And it's a very simple thing. All you have to do is look at the power on the factor. So let me show you in red what the powers on these factors are. The power on this factor, right? This is x being squared, that's 2, right? The power on this factor is a 1, and the power on this factor is a 1, right? So the multiplicity of this factor is 2, the multiplicity of this factor is 1, the multiplicity of that factor is 1, okay? What the multiplicity tells you is whether or not you are going to bounce at that x-intercept or cross through. See, listen to what I'm saying. Do y'all agree the purple and the green cross through the x-intercept, right? They cross through, but the red one bounces, yes? The multiplicity is what tells you what you're going to do. So if the multiplicity, I'm just going to put mult, is odd, you cross through the x-axis. If the multiplicity is even, you bounce. Okay? You bounce. So look at this x squared, right? What's the multiplicity at x squared? 2. 2 is what? Even? I'm going to bounce. So at this x-intercept, right? Where did this come from? I know that I'm going to bounce here. Okay? Then the multiplicity on this factor is 1. If you follow that factor down, that's this x-intercept. Here we're going to cross because this multiplicity is odd, right? And then x minus 5, that's odd. I should cross at that x-intercept as well. If you have this, you have everything you need. All right? That's everything you need to graph it. Any questions on how I got bounce across here? All right, so let's get a picture then. Let's erase this. I'm going to start over with it. Start from the beginning. I have an x-intercept at 0, an x-intercept at 3, an x-intercept at 5. I know my left side goes up. I know my right side goes up. Okay? And now what I'm going to do is connect everything together with a smooth curve. And I'm going to make sure that when I get to 0, what am I going to do? Bounce. Okay, let's start doing it. Get to 0, I'm going to bounce off. Okay? Come back up. How high do I go? I don't care. Okay, we don't care in this class how high it goes. If you want to go way up and come back down, that's fine. If you just want to barely go up and come back down, that's fine as well. Now what do I do when I get to 3? Cross through. So I cross through. How low do I go? However low I want. Turn back, then go up to 5, cross through at 5, and everything should connect together real nice. All right? This is all we're looking for in this class. We're not trying to find the peaks and valleys. We're not real concerned about all the little precise details. That, again, that's calculus. Calculus 1 is where you get into, like, what's that? What's that point? What's that point, right? That's where we do that, all right? Okay, let's look at the computer. Let's see what the computer got for us. I'm going to have it graph that one. What do you think? That's the computer's picture. What do you think of the computer's picture versus ours, right? They both pretty much tell us the same thing in terms of, like you can tell here where the graph is above the x-axis, right? This graph is over here, it's above the x-axis. Between here and here, it's above the x-axis. From 5 on, it's above the x-axis, just like that says. And then here, between 3 and 5, we're below, right? Okay, this is our goal, all right? This is our goal, is to be able to do this for all those functions sitting there, all right? But I've got bad news. This factored, didn't it? Real nice? Those aren't going to factor like that. So this was just to kind of motivate the idea, all right? Just to be like, okay, see, if we can factor it, then once we factor it, we can figure out the x-intercepts, the bounce cross, and we're pretty much in business, all right? Yeah? Well, you would be assuming 2 is the highest point. You wouldn't know unless you compared it to the numbers next to it, right? So, you could find more points, yes, if you wanted to have a little more detail. But there's no way you could guarantee me that by plugging in 2, that's the highest point, right? Okay, so what I'd like to do now is I'd like to show you your homework assignment, the first part of your homework assignment. It's going to look nothing like what we just did, all right? But the ideas are all there, all right? Let me leave that there in case we need it. So your homework assignment, this is from 5.1, by the way, 5.1. The first part of this assignment says, there it is. We're going to look at number 42. You're supposed to do the odds. So what it wants is for us to come up with a polynomial, okay? Number 42. They're saying that the zeros are -2, 2, and 3, and they want the degree of this to be 3. What they want is for you to come up with any polynomial you want to, anything you can come up with on your own that has these three zeros. Zeros are the same as x-intercepts. So these three x-intercepts, and the degree of it has to be 3. So watch what I'm going to do. I'm going to define a function f of x, and I know that when I plug in -2, I need to get 0, right? When I plug in -2, I should get 0. So I'm going to make a factor, x plus 2. Do y'all agree if I plug -2 into this, it becomes 0? Yes? Then I'm going to put x minus 2, because if I plug positive 2 into this, it becomes 0. And then I'm going to put x minus 3, because here, if I plug positive 3 in, I would have a 0. Do y'all agree those three factors I just created, this function that I just created would actually have these 3 zeros? Yeah? Okay. Now, I need the degree of it to be 3. So let me just check. Is this a third degree polynomial? How do you know it's third degree? You have 3 x's, right? So just to show you, if I multiply these two together, that means FOIL, right? If I did that, I would get, let's see, the x plus 2 is still out here. I get x squared minus 5x plus 6. I'm not showing the work, but that's what you would get if you FOIL that out, right? Then, if I multiplied this out, remember how to do this? Here to here, here to here, here to here. And then here to here, here to here, here to here. I have to do 6 multiplications. Let's do that. So my first multiplication here to here is x cubed minus 5x squared. That's here to here. And then plus 6x. That's here to here. Then plus 2x squared. That's here to here. Then minus 10x. And then plus 12, right? And let's collect like terms. I have x cubed plus 3x squared minus 4x minus what? Minus
Negative 5x squared plus 2x.
Oh, I put, okay, thank you. It's like, what? I thought y'all were talking about this. I was like, no, okay. 6x, take away 10x, minus 4x, and then plus 12. Okay? Is this a third degree polynomial? Yes, right? Yes. Is that the only answer? No, this is not the only answer. Now, let me explain how someone else could come up with another answer, all right? Please pay attention to this because this is important. Another possible answer could be the same thing we just had, okay? You have to have this. There's no way you can avoid this. You must have these 3 factors so that you have those zeros. But you could have multiplied this by any number you wanted. You could have multiplied it by 3, right? And then what would that do? It would just hit this with a 3, 3, 3, 3, right? And that would change the graph. It would look a little different. Or I could have put a -3. That would have been significant.